Hello, my name is Alamu Taddasa. I am medicinal chemist in Addis Ababa University, School of Pharmacy. Today we will see the medicinal chemistry of sulfonamides. Please don't forget to subscribe, share, and like it. Before going to the structure activity relationship of sulfonamides, let's see the classification of antibacterial drugs or antibiotic drugs. These antibacterial drugs, they may be classified based upon the chemical structure or based upon their antibiotic mechanism of action. Let's see first the classification that is based upon the chemical structure. Based upon the chemical structure, number one, sulfonamides. This includes sulfones, sulfamethoxazole, sulfacetin. They are sulfonamides. Number two, quinolones like naldexic acid, ciprofloxacin, inoxacin, gatifloxacin. Number three, beta-lactam antibiotics like penicillins, cephalosporins. Third, aminoglycosides like gentamicin, streptomycin. Fifth, tetracyclines like oxytetracycline, doxycycline. The sixth, macrolides like azithromycin, clarithromycin, erythromycin. Seventh, polypeptides like polymyxin B. The last, nitrobenzene derivatives like chloramphenicol. These are the classification based upon the chemical structure. Also, these antibacterial compounds, they are classified based upon their antibiotic mechanism of action. Number one, bacterial cell wall synthesis inhibitors like beta-lactams, vancomycins, isoniazid, ethambutol, cycloserine, bastracin, polymyxin. They are bacterial cell wall synthesis inhibitors. Second, antimetabolites like sulfonamides, dapsone, trimethoprim, paraminosalsalic acid. Third, those drugs that will alter the cell membrane like polymyxin, bastracin, neomycin. The fourth, protein synthesis inhibitors. This may be 13S ribosome inhibitors or 15S ribosome inhibitors. 13S ribosome inhibitors, aminoglycosides, tetracyclines, oxazolidines. 15S ribosome inhibitors like chloramphenicol, macrolides, clindamycin, streptomycin. The fifth class, based upon the mechanism of action, nucleic acid inhibitors, nucleic acid replication or transcription inhibitors, RNA and DNA formation inhibitors like quinolones, metronidazole, rifampin, and rifabutin are some of the examples of drugs that are classified based upon the mechanism of action. Let's see. Sulfa drugs. What are sulfa drugs? Sulfa drugs, they are compounds that contain the aromatic ring that is directly connected with sulfamoyl moieties. They have para-nitro group, NH2 group in their structure. These compounds, they are known as sulfonamides or sulfa drugs. Here we have the general structure of the sulfa drugs. Here is the general structure for sulfa drugs. Also, we have here the general structure of sulfa drugs. Sulfa drugs, they contain aromatic ring. They have at one position, they have sulfamoyl moiety. At para position, they have amino group, NH2 group. These compounds, they are called sulfonamides. By the way, the sulfonamides are the first antibacterial agents that are clinically used. Among this one, the prodrug prontosil is the first sulfonamide drug, but later it was metabolized to produce it is a metabolite called sulfanilamide. This is the structure of sulfanilamide, which is formed by metabolizing the compound called prontosil. Prontosil was discovered in 1935. Then by metabolizing this compound, they discovered sulfanilamide. Therefore, to enhance the activity of sulfanilamide, to increase its stability, to increase its safety, to increase its availability, to increase its duration of action, it is important to elucidate the structure-activity relationship, to decrease also the side effect that is associated with this compound. Therefore, this is the general structure for sulfonamides. This is the general structure. This is the general structure. It has a aromatic ring. On the aromatic ring, there is, on the first carbon, there is sulfamoyl moiety. This is sulfamoyl moiety. At the para position, there is amine group. Amine group. Therefore, in the structure-activity relationship, number one, the para-amino group is very important. This para-amino group is very important for activity. Therefore, substitution on the para-amino group will eliminate the activity, antibacterial activity. The para-amino group will not be substituted. It must be unsubstituted. If it is substituted, it can be substituted with esters, which can be easily hydrolyzed. Other groups, if they are substituted on the para-amino group, they may diminish activity. The para-amino group is essential for activity. It must be unsubstituted. And substitution on the other position, places of the aromatic ring, will decrease activity. Only it must be substituted at the para position. That para position must be amine group. Substitution on the ortho position or meta position will decrease activity significantly. Also, at one position on the aromatic ring, there are sulfamoyl moieties. This sulfamoyl moiety is essential for activity. On the sulfamoyl group or sulfa group, there is amine group. That amine group is essential. This amine group, it may be primary or secondary. Tertiary amine groups, they are less potent. They are ineffective. Therefore, this amine group, which is found on the aromatic sulfamoyl moiety, is essential, and for activity, it must be either primary or secondary. But primary amine containing sulfonamides, they may produce toxic metabolites. Due to this one, the primary amine containing compounds, they are not active. They are not used because of their toxicities. Only we can use secondary amine containing compounds. Therefore, many of the sulfa drugs, they differ from each other by having the group on R2. This is R1. R1 is, most of the time, it is hydrogen, or in some cases in prodrugs it may be ester group. Therefore, most of them, they vary here on amine, sulfamoyl moiety amine group, that R2 group. Therefore, R2 group determines its potency, it will determine its absorption, its duration of action. Also, its safety depends upon this R2. That R2 is very important. Therefore, it must be either heterocyclic or the open chain or cyclic compound for better activity. I am not saying that all heterocyclic, they are potent, but substitution with heterocycle will increase potency. In fact, we have some heterocycles that are also toxic compounds. Therefore, Ra2 is the place where many of the sulfonamides they vary. Therefore, it determines the activity, the potency. Also, it determines the binding efficacy with plasma protein. Therefore, it is very important. Therefore, the Ra2 it can incorporate large range of groups. Therefore, here the structure activity relationship of sulfonamides, there are some groups that are discovered. For example, here we have the compound known as sulfa thiazole. Sulfa thiazole is toxic compound. Sulfa thiazole is toxic compound. When this sulfa thiazole when it is acylated, it will produce insoluble compound, which is not soluble in the body, which can cause toxicity in the body. Therefore, conversion of that thiazole group on the sulfa thiazole ring, conversion of the thiazole group into pyridine or pyrimidine, this group will decrease the side effect. Therefore, by changing some groups which are toxic or which are associated with side effects, they develop a large number of sulfonamides which are nowadays which are used in clinically. Therefore, this is the mechanism of action of sulfa drugs. The mechanism of action is inhibition of the enzyme that is responsible for incorporating the para-aminobenzoic acid with other important metabolites to form folic acid. Therefore, sulfa drugs, they are structurally similar with para-aminobenzoic acid. Therefore, they will compete with the binding of para-aminobenzoic acid. Then they will foolish the enzyme that is responsible for combining the pteridine, L-glutamine, and para-aminobenzoic acid. Then they allow or they result in the leakage of bacteria. Some of the antibacterial sulfonamides that are used, that are developed from sulfa drugs are sulfacetin, sulfadoxin, sulfathiazole. Later it is modified. Sulfadiazine and sulfapyridine are some of the examples of compounds. Also, we have other anti-metabolite compounds like trimethoprim. This is anti-malarial compound. Also, we have sulfone. It is anti-lipotic agent. Here, these are also, they are used as anti-metabolite. They antagonize the metabolite which is responsible for formation of folic acid in bacteria. Here, both of these drugs, sulfa drugs and trimethoprim, they are anti-metabolites, but they differ on the enzyme which they antagonize, which they inhibit. Mainly the sulfa drugs and the sulfones, they inhibit dihydrofolate, dihydroteroate synthesis enzyme. They inhibit this enzyme, but trimethoprim inhibits dihydrofolate reductase enzyme. Also, sulfa drugs, they inhibit dihydroreductase enzyme. That is the difference between the two drugs. Sulfones also, they inhibit dihydroteroate synthesis enzyme like that of sulfonamides. But trimethoprim, it inhibits the conversion of dihydrofolic acid into active folic acid by inhibiting the enzyme that is called dihydrofolate reductase enzyme. This is all about the mechanism of action and the chemistry of the sulfa drugs. I will come with the chemistry and the structure activity relationship of beta-lactam antibiotics. Thank you.